exactly two parallel sides. We call the parallel sides the bases, and the other two sides that aren't parallel, we call them the legs. So again, we're going to kind of go through how the trapezoid area formula is derived. Right? So first off, the bases are these parallel sides. So I'm going to call this B1 and this B2. Okay? And then the height of a trapezoid is just like the height of a parallelogram. I'm going to draw a line right there, and that's the height. Okay? So to begin with, define the area formula for a trapezoid. First, take this trapezoid, make a copy of it, and flip it essentially over. Okay, so make a copy of it and then flip it over. So notice now this is the long base, B2, and this is the short base, and we still have the same height. Okay, so make a copy of that. Now, kind of like what we did with a, not a rhombus, a triangle, right? We can slide these two. Imagine sliding these two together, and we get a really long parallelogram. Okay. Now again, this is base 1, this is base 2, and this guy over here was base 2, and this was base 1, and this was our height and height, right? Now, the area of a parallelogram is still base times height. But the base of this parallelogram are both of these bases put together, base 1 plus base 2. And so the area of this parallelogram, I'll just say A sub par, would be base 1 plus base 2 times the height. But there's two of them, right? The parallelogram is actually two of our trapezoids. So one of our trapezoids would be half of this. So the area of any trapezoid is 1/2 base 1 plus base 2 times the height. So this is the formula we're going to be working with today for area. So for the test, you'll be allowed to use a note card, just like the last test. And so you're going to probably want to write down all these area formulas we've been talking about. You have them in your notes, and I'll give you a note card tomorrow to fill out. But you can start consolidating now if you want. All right. And then to find the perimeter of a trapezoid, it's just we add up all the side lengths. That's how we find the perimeter. Okay. So it says in the following examples, find the lengths of the two bases, the height, and the area. So each trapezoid is going to have two bases, so base 1 and base 2. Now it doesn't matter which one we call base 1, which one we call base 2. It doesn't matter at all. It's just a way of keeping them separate. So I'm going to call this one base 1, the top, so that'd be 10. This one, base 2, then would have to be 12. Okay. And then the height is the distance between the two bases. So notice the height is always perpendicular with the two bases. So this is a right angle also, we just don't need to draw it. So the height here would be 5. And so our area would be 1/2 times base 1 plus base 2, so 10 plus 12, times the height of 5. I think this is where a calculator is coming really handy. Of course, 10 plus 12 is how much? And half of 22 is 11. So 11 times 5 is 65. So we got two bases, got our height, now we've got our area. Remember, it's multiplication, so order of commutative property says we can multiply in whatever order we want. So multiplying by 1/2 is the same as dividing by 2.
No, what I'm saying is that isn't it supposed to go over the 5 too? And 5 by 2.
Well, okay, so you could do 10 times 12, which is 22, and 22 times 5 is 110. 110 divided by 2 is 55. So again, it's commutative, so multiplication you can multiply in any order. it's the 2 times 3 times 4 is the same as 4 times 3 times 2. Doesn't matter. And so if I change that 2 to a half, right, still doesn't matter. Okay. So moral of the story, we multiply whatever order is convenient. Okay, example 2. Let's see here. So we're given this label of 10, right, and this label of 8. Now, the whole trapezoid here has a base of how long? 14, okay? So base 1, we're told, is 8. Base 2 is 14. We aren't given a height, but we are given an angle, which means we can use a trig ratio or a special right triangle, whichever one you feel comfortable with, to find the height. And so if I call this side x, in reference to the 60-degree angle, that's the opposite side. And then this length right here, the 4, is the adjacent side. So we'd use tangent. So opposite, adjacent. And so tangent, I don't want to do it over here. I guess I can do it right here. Tangent of 60 equals opposite over adjacent. And so x would be 4 times the tangent of 60. .9282. Okay. So our height is 6.928. Which, by the way, what is 4 square root of 3? Type that in your calculator. 4 square root of 3.
6.92.
Yeah, so remember, this is a special right triangle as well. So knowing this is 4, that would make this 4 times the square root of 3. So we don't have to use the trig ratios. We can also just recognize the special right triangle. Okay, so we've got base, we've got height, we've got base, base, and height. And so we've got area is 1/2 base 1 plus base 2 times the height of 6.928. And so we get 76.208. Okay. Work. Base, base, height, and area. Okay. So again, just like previous assignments, when we have an angle, we can usually use that to find something. Okay. Number 3 says also find the perimeter. So we're going to find our base 1, base 2, height, area, and the perimeter. Okay. So based on the labels, base 1 would be either 15 or 20. Base 2 would be the other one, so in this case 20. Now the height isn't drawn here. The height is that distance, which is the same as this side, but we don't know either one. Okay. So do we know anything else that deals with this height? Okay, we have an angle. And so since this is 45, this is also 45, and this is a right angle. All right. Do we know any side lengths here? Can we figure out any side lengths? I guess the better way. So this is 20. All right. So if this is 20 and this is 15, this must be 5 because this part must be 15. All right. Now, what kind of a triangle is this? Isosceles, and how do we know it's isosceles, by the way? Okay, because these are both 45. And so if this side is 5, this side must also be 5. The same. And then recall for 45, 90s, the relationship is x, x, and then x times the square root of 2. So this would be 5 times the square root of 2. So the height of our trapezoid is 5. Let's say I forget the special relationship that is isosceles. What else could I use to find that this is 5? Use a trig ratio. Which one in particular, if we knew this side? Okay, so we'd use tangent also because it's opposite and adjacent. So tangent of 45 equals x over 5, and then solve that and you'll see it should be 5. So our area, we've got 1/2 base 1 plus base 2 times the height. And so we get an area of 87.5. So let's find the perimeter. So to find the perimeter, we're going to add up all 4 sides. So we know, we already knew the top and bottom, so 15 and 20, right? We knew the 2 bases. Its diagonal length is 5 times the square root of 2. Again, if I don't remember that relationship, I would use, well, this is 45, I know this is 5, so adjacent hypotenuse, so I'd use cosine, right, to find that length. Oh, it's a special right triangle, so 5 root 2. So I've got 1, 2, 3 sides. How many sides does the trapezoid have? 4. So I'm missing one. Which side? This guy right here. And how long is that? It's also 5. It's the same as this one, right? So these are the same length. So this is also 5. And so I'm at 47.071. I recall that the median of a trapezoid is the line segment joining the midpoints of the 2 legs. So draw a trapezoid right here. Okay. And if we go to the midpoint of each leg, remember that line is called the median. So we have base 1, base 2, and this is called the median. And what was the relationship between the length of the median and those other 2 legs, the bases?
The base is 2 times.
Not the base. So if we average the 2 bases, we get the median. Right? So if we average the 2 bases. So we have 2 bases, right? So to find the median, it'd be base 1 plus base 2 divided by 2, which is the exact same thing as half of base 1 plus base 2. Have we seen half base 1 plus base 2 any place today? Yeah, in our area formula, right? Right here, half base 1 plus base 2. So that's kind of the point of the story. So since the area and the median formulas both have half base 1 plus base 2, an alternate formula for finding the area of a trapezoid is area equals median times the height. Okay, so we're given a trapezoid, which notice these represent congruence, and these represent congruence, which means that these 2 points are the midpoints of the 2 sides, which means 52 is the median. And then notice this this line right here is perpendicular to the base, so this is the height. So the area would be median 52 times the height of 25. 1,300 is our area. And then the last example, if a trapezoid has an area of 79.2 square meters and a height of 4 meters, what is the length of its median? Okay, so we have an area, we have a height, and we're asked about the median. So we want to write down the formula that involves those 3 things. Okay, so area equals median times height. Now, are we squaring 79.2 right here? Okay, remember, this is just a unit. It's not. We're not 79.2 squared. It's just 79.2. So an area of 79.2 equals. Now we don't know the median, right? So I'm gonna call that M. Don't feel like writing med even. And then times the height of 4. So how the heck are we gonna get M? Divide both sides by 4. And so the median is 19.8 meters. All right, so there are 10 problems finding area, perimeter, and so on a trapezoid. For the first 4, notice, read the instructions. It says find the length of the 2 bases, so B1, B2, height, and the area. You're not asked to find the perimeter on the first 4. So don't try to, because there's not enough information given to find it. Okay? Once you get to number, yeah, 9, ask for perimeter. Right? Only one of these is asking for the perimeter. So don't try to find the perimeter if it doesn't ask for it. Okay. Questions or concerns on these, 5 examples? Yeah. The first page. That bottom part. So we're using the same formula repeatedly.